Good day. Quickly do the calculations, which will be visible on your screen just now, and then we will mark it in just a second. Grade 8. Before we mark the calculations, have a look at the following. I have -5 squared, and I have -5 in brackets squared. So what's the difference? Is there a difference? Let's have a look. I have -5 squared. This squared is only there with the base 5. So I need to say it's -5 times 5. So it will be -5 times 5, and the answer will be -25. The second one, I have -5 in brackets squared, which means that it is -5 times -5. You can write it like this, -5 times -5. And a minus times a minus becomes a plus, and 5 times 5 is 25. Let's have a look at the next one. The square root of -4. Meaning, what times what is -4? If you deal with the number first, you can say what times what is 4? It's a 2. But now to get a negative, I need to say what sign is being multiplied by itself to give me a negative. Let's try. A negative times a negative. Oh, it's a plus. And how about a plus times a plus? It's also a plus. So I cannot get an answer here, which means if you check it on the calculator will show it is a math error, which means that the square root of -4 is undefined. But the cube root of -8. What times what times what is -8? Let's do the number first. What times what is 8? A 2. And now the sign. What times what is a negative? Let's try. A negative times a negative, it's a positive. And a positive times a negative, it's a negative. So I can actually write this as the cube root of -2 cubed. And then the cube root and the cube will cancel each other out as they are opposite operations. So my answer will be -2. Let's mark the calculations now. 2 times square root of 4. Boys and girls, if you have a number in front of a square root, then it means it's multiplication. It's 2 times the square root of 4. So 2 times, and what's the square root of 4? A 2. Minus 3 times the square root of 9. So it will be 3 times 3. And here, 2 times 2 is 4. Minus 3 times 3. Remember, BOTMAS, you need to do the multiplications first. Is 9. And 4 minus 9 is -5. The next one, number 2. Oh, I put this one in on purpose because I know that you guys can easily be in a flat spin once you see something like this. The square root of 81. Phew. Start from the center, from the core. Let's have a look there. Can you get the square root of 81? Yes, the square root of 81 is 9. But I still have the big square root there. So I need to work out square root of 9. And can you get the square root of 9? Yes, the square root of 9 is 3. Number 3. I have the square root of 0,0016. My suggestion will be take your decimal number and write it as a common fraction. So I have the square root of 16. And what there? 1, 2, 3, 4. It's 4 places behind my comma, 4 decimal places. So I will have 4 zeros in my numerator. 1, 2, 3, 4. Sorry, my denominator, not numerator, denominator. So 16 10,000ths. And can you get the square root of 16? Yes. Can you get the square root of 10,000? Yes. So I can say the square root of 16 is 4. The square root of 10,000, what times what is 10,000? It's 100. 4 over 100. And now it's important to read your question again. Make sure what they ask. If they ask you to leave the answer as a decimal number, then you can write 400ths as a decimal number by saying 0,04. But if they state that they want the answer in a common fraction in the simplest form, you need to simplify 400ths now. So, what can divide into 4 and into 100? That's the same number. A 4. 4 can go into himself once, and 4 can go into 125 times. So, boys and girls, you can see that 0,04 is exactly the same value as 1/25. Question number 4. Let's have a look. The square root of 16a squared minus 3 times square root of a squared. It's 2 terms, and we can deal with them separately. Square root of 16, yes, it is 4. Can you work out the square root of a squared? Yes, it's a. Minus 3 square root of a squared. So here they are actually opposite operations. So it will be 3a. And 4a minus 3a is 1a. You can also leave the answer just by writing an A. That's also fine. Question number 5. How many terms do you see? There's actually only one term because the numerator and the denominator, they are being multiplied. All the values, they are being multiplied with one another. So it is one term. So let's deal with the numbers first. In the numerator, I have 24. In the denominator, I have 27. Can I simplify that? Yes, I can divide it by a 3 in the numerator and in the denominator. How many 3's can go into 24? 8. And how many 3's into 27? 9. So it will be 8 and 9 there. Now have a look at the x. I have x to the power of 4 in my numerator, and in my denominator I have just one x. So now you can apply the second law of exponents that said, if the bases are being the same and they are being divided, what do you do with your exponents? You subtract them. So I can say 4 minus 1 will be an answer of x to the power of 3. You can also say, I have 4 x's in the top and 1 x at the bottom. If I cancel out, what will be remaining? X to the power of 3 in the numerator. Let's have a look at the y, the base y. I have y squared, so I have 2 y's in the numerator. And here, y cubed, I have 3 y's in the denominator. If I cancel out, how many y's will be remaining? 1 y in the denominator. The z. I have 1 z here in the numerator and 4 z's in the denominator. So if I cancel them out, what will be remaining? 3 z's in the denominator. Boys and girls, careful that if you write a z, that it doesn't look like a 2. So that's why I have my horizontal line there. So you indicate that that is a z. Question number 6, last one. I have 3x squared y cubed, and then I have 2y cubed in my first part, multiplied by negative 2xy cubed, and then negative 9x to the power of 6. Okay, so let's see. I have actually only one term because they are being multiplied. So what can I do? Let's deal with the different parts separately. So here I have my 3x squared y to the power of 3. I cannot do anything with that, so I will leave it as it is. 3x squared y to the power of 3. In the denominator, though, I have a 2y cubed, which means it's 2y times 2y times 2y. So I can say, let's cube the first two first. Or actually, I'm applying the third law of exponents that says, if I have an exponent outside the bracket, I need to multiply the exponents with the exponent inside the brackets. So there I have 2 to the power of 1 and y to the power of 1. So then I will say it's 2 to the power of 3 and y to the power of 3. Multiplied by negative 2xy cubed, in brackets, cubed. So I can say, right, let's do the sign first. A negative times a negative times a negative. It is a negative. 2. Again, I can apply the third law of exponents, saying that the exponent outside the bracket should be multiplied with all the exponents inside the bracket. So I would have 2 to the power of 3, and then x to the power of 3, and y to the power of 3 times 3, 9. In the denominator here, I have negative 9x to the power of 6. I cannot do something there. I'll leave it as it is. Okay, and now we can start with the fun part because we can cancel out. Let's have a look at our numbers first. I have a 3. I have a 2 to the power of 3. But wait, I have a 2 to the power of 3 there as well. So actually, I can cancel those out. If you maybe wrote an 8, then it's also fine. You can cancel out the 8. It doesn't matter. So I still have a 3. I have a 9 there in the denominator. So 3 can go into myself once and into 3 times. Okay, I've dealt with all the numbers. Now let's have a look at the variables, the base x. I have x squared and an x to the power of 3. But they are being multiplied. First law of exponents. Bases are the same. They are being multiplied. What do you do with your exponents? You add them. So I need to write now what we have. So let's just go back to our numbers. I have here only a 3 in the denominator. My x's. I have x to the power of 2, x to the power of 3, will become x to the power of 5. Now, my base y here. Y to the power of 3 times y to the power of 9. But, I have a y to the power of 3 here as well in the denominator. So you can cancel them out. I have my y to the power of 9. I do not have other y's, so it's y to the power of 9. And then I still have remaining my x to the power of 6 in the denominator. X to the power of 6. But what about the signs? A negative divided by a negative becomes a positive. Right, so boys and girls, I have there x to the power of 5 divided by x to the power of 6. If you cancel out the x's, what will be remaining? 1x. Where? In the denominator. So let's write the final answer. Y to the power of 9 and 3x to the power of 1. You can also have there that 1 saying that I had a 1 when it cancelled out the 3's. Boys and girls, I hope you understand these calculations now better. Until next time, goodbye.